Let's continue on with the line and line segments part. So it's the very bottom of page 31. It says lines and other curves. Go to page 32. Okay, graphing a line segment. Graphing a line segment. Okay, so let's draw and identify the graph of the parametric curve determined by that. X equal to 3t, y is equal to 2 minus 2t. So this is example number 4. Okay, in example number 4, it says we have x is equal to 3t, y is equal to 2 minus 2t. Okay, and we're going from t is equal to 0 to 1. And we want to find out where it's going. So t is 0 to 1. And we want to find what? We want to draw and identify the graph, okay? So when t is equal to 0, what's happening here? When t is equal to 0, x is equal to 0, y is equal to 2. So that is actually what? The point 0 and 2, right? So 0 and 2, right here, 0 and 2, okay? When t is equal to 1, which is the end point, right? So I start from the 0 and I end at 1. And when t is equal to 1, I get x is equal to 3, y is equal to 0. So I get 3 and 0. So I'm going to start from 0, 2. This is my starting point, and I'm going to draw a line straight down like that. Okay, so it's a line, it's not the full line, it's just that line segment. So let's take a look here, what's happening. When t is equal to 0, this is what I have. When t is equal to 1, I'm at this point right here. Okay, so can anybody tell me what this 3 here means? What this 3 here means? This 3 here means that from 0 to t, I went from 0 to 3. I went from 0 to 3 in the x part. I went from 0 to 3. And the negative 2 here means that I started at 2 in the y, and then I end up dropping 2, the negative 2. Okay? So that's what those things are. So if you were to rewrite this, if I move this 2 over to the other side, what do I get? I get this becomes a minus, and I'm going to have like that, right? Okay. Now this makes it more clear, a little clearer. Okay. So this makes it a little clearer here. What makes it clearer is that now I can see that I start where x equal to 0, y is equal to 2. 0 and 2, this is where I started from. Okay, this is where I started from, this point, 0, 2. Okay, and during the time interval, I went 3 forward in the x direction, and I went 2 down, negative 2 down in the y direction. Okay, and that's what those things are. So 3 and negative 2. Does that make sense? You understand that? How would I change this from a line segment to the entire line? The entire line would be what? In order to change it to the entire line, I would go ahead and change this guy here to that. In other words, there would be no restriction in time. It would go all the way from here all the way down there. Okay? All right. So let's move on to example number 5. Example number 5 is actually the same thing we just did, but we're going to go in reverse order this time. Okay. Example number 5, it tells you find a parametrization for the line segment that with endpoints negative 2, 1, 3, and 5. Negative 2, 1, 3, and 5. So we're going to have negative 2, 1, -2 and 1. And what was the other point? 3 and 5. So it would be 3 and 5. Boom, like that. Okay. And again, we're going to do, so we're going to, let's think about what we did in example number 4. Okay, so we're going to try to set, so this is going to be equal to, t is equal to 0. And we're going to set this guy as t is equal to 1. Okay. So what do we have? We have -2 and 1. So if you think back of what we did in example number 4, I can say -2 and 1 is equal to, right, something t and something t. I can actually figure this out if I wanted to, right? In the x direction, I went from -2 to 3, so I moved 5, right? So actually, this is going to be 5t, right? And the y direction, I went from 1 to up to 5. So I grew or went up by 4, right? So that's how I would work that, okay? So my answer would be this. So my parameterization would be to just take this x and say, now this is 5t minus 2, y is equal to 4t plus 1. And that would be from t is 0 to 1. Okay? So that would be my way of doing it. The book gives you a different way. The book gives you, actually what he does is that instead of looking at the graph, what they do is they're going to say, we're going to call this A. I don't know what it is A, and I don't know what it is B. But I do know when t is equal to 1, x is equal to 3, and y is equal to 5. So I'm going to put that in here. When t is equal to 1, x is equal to 3, y is equal to 5. What do I get here? So when x is equal to 3, I'm going to get 3 plus 2 is equal to a times 1. That was t is equal to 1, that's where that 1 is, which means that a is going to be equal to 5, right? So a is going to equal to 5, just like we solved it earlier. And over here, when y is equal to 5, so I'm going to get 5 minus 1 is equal to b times t is equal to 1. So b is going to be equal to 4, just like we found earlier. So then we're going to go, say this is 5 and 4, and then we're going to move the 2 over and move the -1 over. Okay, so that's how the book did it. The same thing, really. Okay. All right. Any questions there? Are we good? Okay, this seems pretty innocuous and it seems pretty easy, but I would definitely make sure that you understood this. Because this is one of those questions when I put it on the test, I guarantee that half of you will not get it right. And therefore, it'll probably be on the test. Okay? Any questions? Anybody have any questions? No questions? Okay, I am done for the day. You guys